Hello, welcome back everybody. Hope you had some time to stretch and drink some water. Our next speaker is Gustavo Ambrozio, and I believe you're doing a live talk.
Yes. Can you hear me?
And yes. And
All right.
so if you guys have any questions for Gustavo, go ahead and type it in the Slack channel and he will answer them at the end. And also make sure to check out the Bugsnag demos. They are today at 140, 220, and 250. All right, so I will leave you to it, Gustavo.
All right. Thank you. Good morning, good afternoon, good evening, wherever you are. I don't know. It's morning for me here. Well, today we're going to talk about my title of the talk was Code Reuse with Protocols, Generics, and Extensions. The subtitle was a little bit different, but I realized while preparing for this talk that what I was doing was actually a way to create abstract classes in Swift. So then I changed my subtitle and the talk a little bit. So let's talk about what is an abstract class. So for those of you who never did Java or like C++ also has that, it's kind of a mix between a class and a protocol, like in Swift, right? And it's a class that cannot be instantiated. It's abstract, so it can't instantiate an abstract class. And they do not exist in Swift. Well, until now they didn't. So let's see uses, examples here. So an example of an abstract class that what would look like in Swift is something like this. Let's say that we have a class that we want to make share photos, right? But we don't know where we're going to share this yet. So we know we're going to have a few things in common from all the sharers. So we're going to need obviously an image. We have to have an initializer with that image. And let's say that we want to crop that because we want to do everything square for whatever reason in our class. But then this share function, we don't know what to do because it depends on where we're going to share with. Like if we're going to share on Twitter or Instagram, it's different. So we would declare that class, that function as abstract, and then you don't have to implement that. So in a way, you see how this is a mix of a class and a protocol, right? Like this would be something that you would put inside of a protocol. And then if you were to implement your Twitter provider, right, the only thing that you have to do is subclass from your abstract class, and then Swift would require you to implement the share function because it's an abstract in your superclass. So that's what it would look like, but we cannot do that. If you write that, you get nothing. So let's see if we can do this in Swift. So let's try that. Let's do the first thing that came to mind when I needed to do something like this is use a protocol with an extension, right? Like that's what everybody's probably thinking right now. That's a perfect use for that. So you write a protocol of your provider. You know you need an image. You know you need the crop function. You know you need a share. So you declare those in the protocol. And then in your extension, you can implement the crop function. You can't implement everything else because you can't have properties in extensions. So you still can't do that. And then in your structure, this would implement the photo share provider. It's missing there. Then you would have to implement, you have to declare your image, you can declare your initializer, and then you do your share function. So not exactly like what we wanted, because you have to repeat a lot of stuff. In this case, it's just like the property and the image. But you can imagine in a more complex example, it would be way more than that, right? So it's not exactly what we want here. So let's, oh yeah, then if you have like an Instagram, again, see like there's a lot of repetition here. We don't want that. So let's try again. So let's see if we can do this with subclassing. Subclassing is another way that we can try. So let's see. So let's create this photo share provider as a superclass. And the way we would do this in Swift, we would have our property initializer. We can implement our crop function. But the share function, we don't know, right? We don't know what it is. So we use this trick about the fatal error and then must override. And then when you're doing your subclass, then you implement the share again. There should be an override there. And you have to know to not call super for obvious reasons here, right? So this works. It kind of works. It's kind of like the same thing, right? But there's a few drawbacks here. The first one is the fatal error. I particularly don't like this trick because it looks bad. If you have a linter looking at your code, you might be checking for no fatal errors in your release build and something like that. So that's really doesn't really work. You also have to always remember to not call super, right? Like you have to have like this comment there because a new developer might come in and say, hey, we're not calling super in this override function here. What's up with that? And then they add that super.share and your app's going to start exploding, right? So not really nice. I really don't like that. Swift also doesn't require you to implement the share function, right? It's up to you to know, okay, I need to do this. When you're testing, it's gonna crash. So not ideal. So not what I like. Also, it needs to be a class, right? You cannot do this with a struct because structs you cannot subclass structures for obvious reasons. It's not a class. You can subclass. So let's see if we can do this again. So the third time, I think, is a charm. So what I tried doing is something like this. So I create a struct that I call photoshare provider. I get my property, my initializer, I get my crop function. But again, I don't know what to do in the share function. So what do I do here? So what I came up with is to create a protocol that I call a configuration, right? And in this protocol, what you do is you put all the abstract functions that you want in your class as static functions that take in your class as one of the parameters, like here. And the way that you use this now, you add this as a generic in your main structure. And now that you have this as a generic, what you can do is you can come here and say config.share using self, right? And then this protocol now serves as a configuration, right? It doesn't have to be instantiated. It's not something that you create at runtime. It's just a configuration that you can associate as a generic in your structure. And then with that, you have to switch there because now your photoshare provider is a generic. So you have to declare that as generic in your protocol as well. But you can do that simply by using self because you yourself is that generic. So you see, it's an interesting way that we create like a circular reference here where your struct has a reference to your protocol and your protocol also has a reference to your struct, but it's okay. Like Swift somehow can manage that. It doesn't bother Swift that it's a circular thing. It can resolve everything. So what an interesting surprise to me that this is done. And then remember here, this is our protocol. Then when you're implementing something, you can create an enum, like you can create a caseless enum, because remember, you're never going to instantiate this configuration. This configuration is just something that you're going to provide as a concrete protocol implementation. So creating a caseless enum is good for that. You don't have to provide anything. And then you're going to have to provide this static function. Swift is going to require you to do this, and then you can use everything from provider. So provider in this case is kind of like yourself. You could even call this self and then use self everywhere, but your provider is kind of like yourself if you don't want to think about this as being a static, as being something that is part of the photo share. And now that you have this, your concrete struct can be just a type alias. So you're not subclassing, because you can't, because remember, our photo share provider is a struct, but you can kind of do that subclassing just by using a type alias. And now you can just initialize this Twitter share provider. So it works pretty well. It's kind of like, it's very, very close. You still have to use this trick about the static, but it's pretty close to what you want. So let's take a look at a real example of when I kind of created this. So it's a very simplified example of something that happens on our app. So in our app, I was implementing something to help us index stuff in Spotlight. So I created what I call a search provider. So the search provider, first we declared this protocol search result, which has a string name, which is what we feed it to Spotlight for indexing. We have this protocol search provider, but then we're going to implement that in various ways, depending on what we want to feed to Spotlight. So simple is going to have a function that's give me any publisher of search results for any term. Now the provider figures out what you do, right? It can read from a file, it can go to the server and asynchronously provide as many results as it wants to this any publisher. And we're also going to have a method called go, which is going to route me to a result. So whenever the user clicks on a result, I'm going to have to route that user to the result. And the app has to do the right thing. So we have a router to do this. And let's say that a router has at least these two methods, like to open a URL and to open an arbitrary view controller. And we're going to see how these are used. So let's see an example is articles. We have articles in our app that we show our users. So an article is going to have a URL and a name. It implements the search result. So the way that we implement the search provider for this case, like we can create a struct. And in this case, again, it's simplified. In our Rio app, we use GraphQL to go fetch that. But to simplify the examples here, let's say that we just read that from a file, and it's a JSON encoded article. So we can just parse that with Swift, and in the initializer, we save these results. So whenever results gets called, we basically just spit out the results, right? Again, simplified. We don't use the term for this, but just for the purposes of this example, the publisher just publishes the sequence for us. And then the go-to result just is going to use our router and open that URL. And then our router is going to be doing whatever the router does. So we also have colleagues. So let's implement something that's going to fetch the colleagues of a user. And again, we use GraphQL. So the structure was really the same. So let's pretend that it's the same here, that we're also reading from a file, from a JSON file. So you can see that it starts to look like very much the same, right? So we read from a JSON, save that, and then our results is just going to publish that with the publisher. And our go-to is different, right? Our go-to now, because we have colleague pages, we have a colleague view in our app, we can use that UUID from the result, from the colleague result, and we can send you to a native interface for your colleagues. We don't open a URL in this case. So now it's different, right? So this is, if you look at this now, right, if you look at both of them side by side, you see there's a lot of similarities here. It's just basically that go-to and the types are different, but everything is pretty much the same, right? So this is something that we don't want to do. We don't want to keep repeating code all over again, because again, we're going to have another example of something that comes from the server and it's going to look exactly like this. We want it to be able to be easy to implement this a third time without having to repeat all this boilerplate code, right? So let's see what we can do here. So this is the first try that I did, trying to re-implement that as a generic struct. So our type is generic now. That's one of the differences that we had. So we can have something that just, again, reads from a string, is the same thing, but now I use T as a type instead of using my concrete type, but everything is the same. My results, pretty obvious, it's the same thing, doesn't change at all. But then when I get to the go-to, now it's different, right? Like I can't tell you based on the search result how to route this, right? Without doing like if else, which would be ugly and unmaintainable again. So this is a candidate for your abstract. This is something that you can create as an abstract function and then use that technique. So let's see what that looks like if we try to implement that trick there. So using that trick, again, first thing we do is put the abstract configuration there. Sorry, the protocol configuration as a generic, as a config there in the search provider. And then my go-to can just use that static method. So you can see the function go-to, and the way that this algorithmic thing works, you always create the same, the signature of your static in the protocol is the same as your function, but with the using self at the end. So this is what your protocol looks like. So you have that goTo function in the protocol that gets a result and gets the result provider. As you can see, because our provider already has a T type, we also have to provide that T type in the protocol. So we're going to have the associated type T in the protocol, otherwise Swift is not going to like this. And because now our protocol has an associated type, you also need to provide this binding here between the search provider and your configuration, where you got to say that your types are the same. So we added this thing here, which is binding the two types. Otherwise, again, Swift doesn't know the relationship between T's, and it's gonna give you an error if you don't put this where here. So in this case here, it starts to get too complicated. But because you have this T already in your protocol, and your protocol is already a generic in your struct, you can use that directly. You can simplify all this, and we can remove that T from our struct as a generic and have only the protocol. And then everywhere where you use T, we just use config.t, right? So we simplify this, and then only the protocol has the associated type. And then we can also simplify that Go function in the protocol. So everything looks nicer now. So when you implement, there's another thing that we can do here, because the configuration, when you implement that configuration, you know that the goTo can't deal with any result, right? Your goTo for Twitter, or your goTo for, in this case, colleagues or news, can only deal with the type that they know of. So you can change that signature a little bit of the result that doesn't get a search result, but get a specific T that that protocol is going to know how to deal with. And then in your superclass, you can guard for that, and you can just make sure that the types are correct before you call your configuration static function, and you can call that with your correct type. So now to implement your colleague configuration, you just implement that as an enum again. You're never going to implement this. You're never going to instantiate this. So it can be a caseless enum. You implement that. Swift is going to require you to create this private function. And because you have the provider, which is yourself in this case, you can use the router from the provider to open the correct view. And again, you create a type alias. So now you can instantiate this colleague search provider as if it was a struct by itself. And Swift knows what to do here. Same for the article configuration. You can just implement that configuration again. Your goTo just looks like it would when we implemented it the first time. It opens in the right way using the URL. We already knows that the result is an article. And again, you just create a type alias, and it works pretty well, right? You can just instantiate this again. So let's recap a little bit. Let's look at how this looks like. So with this, as you've seen, this looks like something that can be repeated. So let's look at the algorithm here to create abstract classes. Let's remember that. So the first thing you do is you identify all abstract functions on a class or struct called abstract X. So we're using everything in a struct here just to show that it works with structs. But if you want to use a class, you can use a class. Everything works exactly the same in a class in this case. And then you make an abstract X. You make your abstract X generic on this config X configuration. This doesn't exist yet, right? So you're going to get an error when you do this. Because it's circular, you have to finish everything until you can actually compile. But it's always easier, from my experience, to create first, put the generic in that class first, and then create a protocol. It makes it a little bit easier. Then for every abstract function, you add a call to config.doc function with the same arguments that you had before, and then you add a using self at the end. Then you can create your X configuration protocol. So in that protocol, what you do is for every abstract function in that abstract X, you add a static function with the same signature and an extra argument using X abstract with the types of self, because you're the one that's going to be that generic in that case. And then finally, for every concrete subclass that you're implementing, you can just create an enum called concrete configuration that implements that X configuration. And when you're done with that, you can just create a type alias of concrete X, which is just your abstract X with your configuration. So there you have it. Like, there's a way now, if you're an ex-Java developer like like myself, and you always wanted to have abstract classes, because it's pretty neat to be able to have this mix of protocols and classes and structs and be able to do something like this. Well, now you have an algorithm that you can create an abstract class in Swift. Yeah, wow, that was like way faster than I did it in my rehearsal. So with that, here's my contact information. Not super active on Twitter, but I do reply when somebody mentions me or somebody DMs me there. This is my work email. So work at Doximity. My boss would not be happy if I didn't mention this. We have jobs open for iOS developers. We're hiring for my team. And if you're asking like, oh, where should I go? Do I have to relocate? It's like, no, you don't have to relocate. Doximity is a remote-only company, not remote only, but mostly remote from the beginning. So we were ahead of the curve when it came to the pandemic. And you can work from anywhere. You can work from where you are, or you can do what I did and move to Hawaii, and you can work from here too. So yeah, take a look at the positions we have open. I believe we have 2 iOS positions open actually. And yeah, let me know if you're interested. And with that, we can open up for questions.
Cool, thanks so much. Let's see. The first question, which is an important one, is do you have a link to your slides?
I do not yet, but I will send it on the channel for sure. I can send that as a PDF or as a keynote for sure. I will share that.
Excellent. And the next question is, in this technique, you pass the configuration statically. How would this compare to a version where you pass the configuration as a value to a regular function parameter?
I see. If I understand correctly, I think it would work. But the thing is that then, let me think here. I think there will be a lot more repetition in this case. If I'm just thinking in my head, I haven't tried that. And I don't know if I understood the question correctly. But if I understand that, if you have to pass a configuration to every abstract method, it's going to get tedious, right? You're going to have to repeat that all over again. So I think it would work, but yeah, I don't think it would look very nice. And then, yeah, no, you still don't have to instantiate your configuration. You can still pass the configuration.self, but it wouldn't look nice, I think. I would have to try it, but I don't think it would look nice.
Okay, cool. Does anybody else have any other questions? I think, are you going to stick around for the rest of the conference on Slack?
Yeah, for sure. Yeah.
Okay, excellent. So then if any other questions come up, you can just hop into there and chat with people.
Yeah, for sure. Yeah, just hit me up.
Cool. So we're going to take a break, and we will be back at 2 o'clock for our next speaker. And make sure to check out those Bugsnag demos if you can.